Right, good morning, folks. I think I will just give it one more minute for people to trickle in before we go ahead and get started. All right. Good morning, everybody. Welcome to the first webinar that we're doing as the Racial Equity Data Subcommittee. My name is Molly Williams. I'm an environmental scientist in the Office of Public Participation at the State Water Board. And I'm here today with my fellow leaders of the EJ Roundtable and the Data Subcommittee, Nick Martirano and Jeneline Guzman. And we're really excited because, as I said, this is our first webinar in what's hopefully going to be a series, kind of continuing education and capacity building across the Water Board and our understanding of how to utilize data and our understanding of racial equity impacts. So just a little bit about our subcommittee. So we are newly formed. We're the only subcommittee of the Environmental Justice Roundtable that Jeneline runs, which is a quarterly gathering of environmental justice practitioners from across the water boards. All of the RDOs are represented. And we recently transitioned the Racial Equity Data Task Force, which came out of our Racial Equity Action Plan, into a subcommittee of the EJ Roundtable. So we are dedicated to building and operationalizing data resources from across the water board and across the state as well, so that we can better understand and promote equity in all of our programs and policies. And we're a very open group. We encourage any and all water board staff who are working on equity data related projects or interested in supporting the mission to join our group. So if you're interested in doing that, we can easily add you. Our next meeting is going to be in a couple weeks. And we'll talk a little bit more about that at the end too, about how to get involved. But today I want to make sure we have as much time as possible for Hannah, our super special guest here today, to do her presentation. So Hannah is representing DataMade, which is a data storytelling and visualization consultant that we've been working with here at the Water Board for a couple months. And Hannah is a former journalist who turned into a software developer who's based in Chicago and has a lot of experience working on data projects for public organizations around the country. So we're really happy that she's here today. And before I toss it over to Hannah, we're going to go ahead and do just a quick poll to get our finger on the pulse of why everybody's here today and kind of what your level of experience and comfort is with some of the coding languages that we're going to be touching on today. So if you don't mind going ahead and completing that poll. All right, looks like we got a lot of people who are interested in the topic, which is an exciting place to be. I think it takes a lot to say you're an expert in R or Python, so, not expecting anybody to be in at that level. Okay, I'll go ahead and end the poll so we can share the results. There we go. So we got a majority of people who are interested in the topic here today, but also quite a few people who are working on equity analyses of their own or are practicing equity programs. Okay, thanks so much for that info. We're going to go ahead and pass it over to Hannah for her presentation. Oh, you're on mute, Hannah.
One day that will not happen. Let me see if I can figure out how to share my screen in the presenter view, which is sorry. Zoom is mad at me. I'm going to quit and rejoin. Molly, will that mess everything up?
No, I don't think so.
I'll be right back.
Okay. I think, Jenilyn, if she has co-host permission, she should be able to share screen, right? Yeah. Okay. Hannah, let me just make you a co-host again.
Okay. I'm so sorry about that.
Oh, no worries.
Okay. Hey, this is where I want to be. And here.
Perfect.
Great. So, yes, we're here today to talk about analyzing data for racial equity. Before we get started, I just want to say a little bit more about me. I'm Hannah. I'm a partner at DataMade, and some of my bona fides at DataMade include working with the city of Chicago on a big project to gather data and then track outcomes from the investment of federal COVID-19 relief. I was here in Chicago, can't remember if I mentioned. Also in the water space, been working with Metropolitan Planning Council here in Chicago, as well as TNC, to get a pilot for stormwater credit trading off the ground, and then through that encourage the development of green stormwater infrastructure. And then also just the through line of most of my time at DataMade is just I'm really into cultivating technical skills in our staff and myself. And then also with a number of folks we work with, done mentoring for data journalists, junior developers, other folks. And so happy to count you all among the friends of DataMade. Offline fiber artist, I love knitting and crocheting. I love riding my bike, and I also have a 5-month-old son. So that is very exciting. Today we are gonna talk about a few things. I'm gonna try and get through them with this time. So first, we're gonna start off with just some working definitions of what racial equity is, go over a couple of frameworks that I believe the subcommittee has already compiled for you. And then we're gonna get into how to get that data and start figuring some things out.
Hey, Hannah, real quick, it looks like we see your notes on top of the screen. If you want
Ah,
to just close, if you don't mind just closing that. Perfect. Now we can
yes.
see it. Yay.
Great, good job. Um, Cool. So working definition, there's a lot of ways you can define racial equity, as we will see. This is going to actually vary a lot based on what you're doing, whether that's the operations of your program or a policy you're considering implementing. But this definition, I think, was really good. It's from the racial equity tools.org website, and it's the conditions that would be achieved if one's racial identity no longer predicted in a statistical sense how one fares. So basically, the not be able to like subdivide data based on race ethnicity and be able to kind of predict what outcomes people are going to face. There are a number also of ways that you might begin to measure racial equity. The two that this have been discussed by or have been mentioned in materials from the subcommittee that I've seen are one from the U.S. Department of Health and Human Services, um, and then one from the Government Alliance on Race and Equity. I included these here because I'm going to share these slides with you, and I just wanted you to see there's kind of like similarities and differences between these, but at a high level, kind of the process that you need to walk through is to define the purpose and intended effects of your program or policy, seek input from experts and community members, and then and add context. Like this can be historical context. This could be vulnerability data. This could be social context, current political context, any sort of context that adds nuance to the definition of your program. Then you're going to collect and analyze your data and determine the actual effects of your program or policy and act on the insights. It's important to consider equity early and then also often. So early because it's easier to measure equity if you have the programmatic data that you need to actually measure what you're what your program or policy is doing. This came up a lot when we were working with the city of Chicago, because a lot of the programs that were funded through the federal COVID relief kind of had to get started very quickly. We're working through subcontractors, and so when they were contracting with folks to actually implement these programs, they didn't have a good sense of what they'd need to measure the impact and outcomes of the programs. And so the subcontractors didn't gather that data. And so there's no really going back and getting data once something has already happened. And so if you can decide early, so whether you're starting a new program, you're evaluating policies, if you can decide like what you're going to collect to evaluate, that's really helpful. And then also defining like, how will I know that I'm operating equitably? What does it look like? So you can use that definition of race, ethnicity does not define or does not predict outcomes, but you can also tailor that to what you're working on. So maybe it's, flood risk, maybe it's, incorporating socioeconomic or household income or household characteristics. You also would often want to establish evaluation cycle. So equity is sort of, it's something that needs to be not only achieved, but also sustained, right? So when you are doing these equity analyses and you're finding, oh, we're missing the mark here, we want to adjust to meet that mark. And then also it's a super helpful sort of cadence for communicating internally, and also an accountability measure. So if you are doing these equity evaluations, like actually be able to share those results and also say what you're doing to ameliorate any issues that you're finding. This is super helpful. So I just want to shout to our lovely host here, take advantage of your resources. There's so many, apart from Forrest and me, the coaches from DataMade. You've got your help email here. They have a really great data handbook and best practices document, and also data project guidance. They're all linked here, and I'm sure you've all already seen that. So without further ado, I want to get into zoom into the parts of the analysis framework that I actually know about, which is the data pieces. So gathering your data and starting to see what's what. Program data, you can collect it via operation, like I mentioned. So if you're at the stage of designing a program, yes, if you're at the stage of designing a program, you can strategically decide what you're going to measure and collect the data, and then use that in analysis. You can also, if you're looking, this is especially useful if you're looking for supporting data sets, or if you're looking to do an analysis of something that's already been in operation, you can retrieve it from a public portal or other source. I linked some useful ones here. I'm sure you all already know about the California data portal. There's the GIS flavor of that portal. It's just geospatial data. I also found a number of other data sets linked on the water board's site that I wanted to mention, just knowing that folks can not always know what resources are available in a giant organization. And then also the data.gov I linked because if you're doing program or policy design and you want to look at maybe if there's a similar thing in other states, that their data might be on the federal data portal. So I linked that as well. This is definitely not inclusive of everywhere you can get data, but these are just a few of the public resources I wanted to share. So this is where it actually gets fun. So retrieving race, ethnicity, and socioeconomic data. We're going to talk primarily today about the US Census products and how to get that data and then add that data to your program or policy data so that you can start doing that analysis of race, ethnicity. But before I do, I also wanted to mention a couple of these other data sets that kind of extend the census products. So CDC has the Social Vulnerability Index that was developed in response to COVID-19. And it's kind of a composite measure that includes race, ethnicity, but also has socioeconomic things, household characteristics, and also housing type and transportation factors. And this is just sort of a more holistic view of like social vulnerability. So if you're looking at something like, water quality or any other kind of factor where overall vulnerability might be something that you want to look into. This is a really cool index that you can use. It's, if you click on this link, you can download it directly from the site by county or census tract. It's great. That's a great question, Anna. I don't know that off the top of my head. But we can get into it together if it's important to you. Cool, we'll put a pin on that and I'll circle back with you. Whoops. There's also the FEMA's National Risk Index. So that also is available by county and census tract, and it is a function of social vulnerability, but also annual loss to natural hazards. So knowing that you all are in California and that you have many things that could happen from, you know, earthquakes to wildfires. Yeah, Valerie, I'll do that. I'll also email this out to you guys after the presentation. So you'll have these links in front of you with the slides, but I'll make sure that they get to everybody. Right. No, so knowing that there's a lot of natural phenomena that could happen in California, if you are looking to incorporate risk or exposure to risk from those phenomena, in addition to just general vulnerability, that's a great index to look at. Let's see. So a couple of ways to retrieve census data. There are the point and click interfaces. So you go to data.census.gov and you can kind of like sort through this very long, complicated table of geographies and variables and surveys and everything. And it's kind of a lot to grok, I think. But that's available as a resource. There's also censusreporter.org. If you've never used it, you can go in and type a topic. So we can look at like race, or Hispanic or Latino origin by race, and then you can drill down into a particular geography. So if we want to look at this in California, we can do that. And then you can go down even further into any of the census geographies. So we can look at the metro areas, we can look at census tracts, et cetera, et cetera. And from here, whoops. From here, you can download it as a CSV, which is nice. But it's still a lot of pointing and clicking and sort of drilling down that can be difficult. So if it's accessible to you, like prefer a programmatic approach. We're going to talk primarily about our methods today, but I did want to shout out Census and Census Area. These are Python libraries that DataMade is maintaining now, but they're just wrappers around the Census API that'll let you retrieve census data and ACS data. The census package will, and then Census Area has the additional layer of returning geographic information, and you can also pass it arbitrary boundaries. So let's say you want to do one of California's like planning regions, or you want to do water service areas, or any other kind of geography that's important to you, you can pass those to Census Area, and it'll give you back the statistics for that area in the form of like tracks or blocks or block groups within the geometries you've passed. But I think let's get to the practical stuff. So in R, the package Tidy Census is very excellent. It's got really nice documentation, which if you're going to use it, I definitely recommend just going through some of the basic usage and spatial data tutorials. But the methods we're going to talk about today are load variables, because if you are like me, then trying to figure out like what are the variables for all of the things, especially for like things that are bucketed or there's many categories. So there's a lot of race ethnicity categories. There's like the income brackets, that sort of thing. Just like I can never remember what's what. Tidy Census has a nice method that's going to retrieve the variables available, and so you can see like what you actually are pulling. And then it has easy methods for either getting data from the decennial census or the ACS. And conveniently, it also allows you to retrieve the relevant geospatial data with those queries as well. So I'm going to pop over to our studio, and we're going to look at how to use those methods we just talked about. So you can see here, we're calling like the load variables method from Tidy Census. We're saying, give us the 2020 data from the redistricting summary file from the decennial census. So we can pop open now the response from that. And we can see now we have this nice list, easy to browse, of the census variables that are available to us. And it's also got the concept. So we can look like, oh, we want race, or, Hispanic or Latino, which is how we wind up getting race. So just having all this listed is really nice. And you can also, it's really helpful, especially when you're trying, say you want to drill down into like mixed race, or you want to drill down into, particular, like Asians from particular different nationalities, that sort of thing. Having all of this listed here is super duper useful. So I will let you all play around with that on your own. What's important here is that this was useful to find out what variables we needed to pull. So to get white, Black, American Indian, Asian, Hawaiian Pacific Islander, other mixed, and then Hispanic demographics for each tract in California. So this get decennial method. Yes, I will share this code as well as the slides. So you'll have this at your fingertips. If you want data for several years, I believe you'll have to do a call this method for each year that you want. So say you wanted 2010 and 2020, you just grab, you can do CA tracks 2010 and change this to 2010. And then you could do CA tracks 2020 and then change this to 2020. Yeah, so I guess that's one important thing to note. So these Get Decennial, Get ACS, they'll give you data from one particular survey. So Get Decennial is getting the decennial census data, and you can pass in the geography that you want. So you can do tract, blocks, MSA, any of the census geographies. You can pass it a vector of the variables you want. You can also just pass it one variable. So say you only wanted the Hispanic population for tract, so then you could just say P2_002N. You can specify the state. Yeah, you can specify the state, and then you'll specify what year and which file. A couple of optional things that I really like that really save me a lot of time is, number one, you can pass in the summary variable argument, which is then it's going to give you with every single record the value for that argument. So for me, I'm always calculating percentages, right? And so this is the total variable for the P2 group of variables. That's the Hispanic race groups. So if we look at CA tracks 2020, or CA tracks rather, you can see that we're getting, this is the also long format data. So you can see we're getting back a row for every geography for every variable we asked for. But with everything, every record, we're getting back the value for the particular variable. So there's 406 white people in the census tract, but we're also getting the total back. So it's super easy to then add the percentage here. The other really cool thing, which is constantly driving me nuts, is trying to get the census geographies. So with Tidy Census, you can just pass this geometry equals true argument, and it's going to include in the response the the shape of whatever geography you have requested. Let's see. So you can see in our CA tracks, so we've got this information, the information we asked for, and we've also got our geometry here, which we can then map. It's not always important for your percentages to add up to 100% if you are, say, just looking at the percentage of Hispanics or the percentage of Black folks or percentage of white people in a particular thing. But if you wanted to check that your percentages add up, I added a little recipe here that just takes the data that we got, does a quick group by, and then adds up the percentages to make sure that everything is squaring up to 100%. As I mentioned, the documentation for this library is super great. I would definitely recommend walking through it. It covers this and so many other things. Yeah, so that's the basics of grabbing census data. So let's switch back over to our presentation. Cool. So this is just the code we went over. I left it here so you can find it quickly if you need it. So now we are going to get into joining the data, specifically spatial joins. So because some of you some of you use Python, some of you maybe use a GUI like ArcGIS or QGIS. I wanted to make sure that I'm providing some of the vocabulary. So if you want to like Google or otherwise look up how to do these things, you'll know kind of the words to look for. So if you have point data, for your program or policy. So that's coordinates, and you want to match that up with census data. So you want to get some variable, we're using race ethnicity. So if you want to get race ethnicity for the tract, because that's what we've pulled, where that point is located, you're going to look for a point and polygon spatial join. That's just going to find like which polygon your point is within. And then if you have aerial data, so that's data representing an area. So let's say we have a count of the number of inspections per census tract. Or usually this is more useful, like if you have tract level data and you want to aggregate it up to a geography that's important to you, like water district or those planning regions or any other thing, you can do a polygon and polygon spatial join, which is going to it's going to give you back this. It's going to tell you which of the larger geographies your smaller geographies belong to. So you can roll it up into that larger geography. The documentation for Tidy Census has really good examples of this polygon and polygon spatial join. It also has some notes about when geographies don't cleanly map onto one another. So census tracts might not necessarily correspond perfectly to water service areas. And so it has some ideas for how to deal with those partial overlaps. But we're going to talk primarily today about the point and polygon spatial joins. And we are going to do that using some complaint and inspection or investigation data for water rights. There's a couple of packages that you one besides Tidy Census, the package you need to know about for spatial joins is SF. That's simple features. It also has excellent documentation, and the methods we're going to use are ST as SF. So that's going to allow you to take a data set with coordinates and make it spatial. ST transform, which is going to change the projection of your geospatial data set, and then ST join, which is going to allow you to join your spatial data sets to do that point and polygon join. So we are going to pop back into our studio session. Here we're just reading in the complaints and investigations data from the California GIS data portal. We're joining them up so that we have investigation data for each complaint. And now we are going to do our join so that we can join in that point data to our census tract data so that we know for each point what are the demographics of the tract that it's in. So the first thing we're going to do, because the STS-SF is going to complain if your data is missing coordinates, is we're going to filter out any records that don't have latitude or longitude. And then we are down here in line 10, going to take our complaint symbol and whoops, and call STS-SF to make it, to add a geometry. By definition, your latitude and longitude are going to be in the 4326 coordinate reference system. But for doing this sort of spatial join, it's good to use a projection that's sort of specific to the area that you're working in. That way the precision is as good as it's going to get. So once we've made it geographic, we are going to project it to the Albers, California projection. ESPG.io is really good. It is great for searching like particular places and finding out which projections are best. But in summary, we've taken our data, we've made it geospatial using the coordinates it contains, and then we have projected it using the Albers, California CRS. So when you're doing a geospatial join, it is important that both of your data sets are in the same projection. So we're also going to call that ST transform method on our track data. Conveniently, this ST join method will complain if you pass it to data sets that don't have the same CRS. So that's nice. But now that knowing that we've projected both of them, we can simply call ST join. And that is really all there is to it. We can just call, guess we should actually run everything in this cell. So we can look at complaints by tract now and see that we have our tract information. And then we also have for each of the complaints. So not all the tracts have complaints. By default, this join is going to be a left join. So it's going to give you back all of the records in the first data set that you pass. And then where there are adjoining records, they'll have them, but yeah. So where there are complaints within a particular tract, you have that information as well. So I used that data to roll it up make a summary file of just the number of complaints by tract. And then we can see I've made, once this finishes running, then I use ggplot to make a little map of what we've got here. So this is census tracts and is a choropleth of the number of complaints by tract. Yes. I am now going to, that's spatial join, so I'm going to pop back into our presentation. And we're going to talk a little bit about analyzing the data. So I wanted to start this section with a disclaimer that I am not a statistician. My compatriot Forrest, who's also a partner at DataMade, is on the call. He has a much deeper statistical knowledge than I do. I'm more of a data plumber. But you don't have to be a statistician to start kind of poking around your data and start doing some sniff checks, start doing some simple comparisons of two groups. So that's what we're gonna talk about here is the high level. The other reason I don't want to get too far into the statistical stuff is that what is appropriate really varies based on what the data is that you're working with. So like a common thing you might do for comparisons of groups is a t-test or ANOVA, but there are lots of things you want to check, like your data is normally distributed, and actually the data we're working with right now is not normally distributed. And so that's not an appropriate thing. But all of that to say, it's subjective, and we would love to chat with you more about the data you're working with and what might be an appropriate statistical treatment to answer the question or questions that you have. But I just wanted to couch that here. Yes. Before we get technical, one thing that I found like this morning that I thought was really cool was the Urban Institute's spatial equity data tool. This is a point and click application, so you just pops open in your browser. You can upload your own data. So I have the data on let's see, inspections. And we'll just do, is that what I picked? Yeah. POI longitude 1, POI longitude 2, or latitude. And then we're going to run the analysis. It's thinking about it. Cool. And what it's going to give you back is kind of a measure of like how representative your data is against the baseline of the state, and then also like by county. There's really good documentation for this, but I thought I was really interested. So if we're looking at points of inspection for water rights, and so we can see like where those are happening. White residents are overrepresented, seniors are overrepresented, et cetera, all the way down to groups that are underrepresented based on that baseline, that state baseline. So we can see like Black residents are underrepresented. Hispanic or Latinx residents are underrepresented in those areas. So I thought this was a really interesting tool. This is kind of the extent of that I've done playing with it, but there's really good documentation here that tells you more about how to interpret these results. And it's a really powerful thing to have, especially if maybe you don't know how to write R, or you just kind of want to do a smell check and see if there's anything that stands out to you. It's a good sort of exploratory tool to get started looking at disparities in your data. So that's linked here. The documentation is linked in this app up at the top. And yeah, I just wanted to share that tool with you guys. So I thought it might be useful. Some of the basic things that I sort of start to look at when I'm like looking at data and trying to look at like differences here are distribution and then some summary statistics. So distribution, you can of course like calculate standard deviation and mean and all of that. I am a very visual person, so I like to look at charts. So ggplot makes it super easy to make just a quick histogram. And then also if you have different groups, you can do histograms for each group. So in our notebook, we have a data set that is like the demographics of each complaint. And I can do a histogram and look at how is the percentage of white or how many tracts have complaints distributed over like the percentage of white. So as the percentage of white changes, how is the number of complaints per tract changing? I'm pretty sure I didn't say that correctly, but you know how histograms work. So we can see if in a higher percentage whites, it looks like there's like a smaller count of tracts with complaints. And then if we break it out, oh no, sorry, this is the overall one on the left. So this is just the overall distribution of tracts, the count of tracts by percentage white. And then if we subdivide it using that facet wrap, we can look at of tracts with the count of tracts where complaints have not been filed, and then the count of tracts where complaints have been filed. So we can see like where they have been filed, it more or less tracks with the overall percentage distribution. But interestingly, if we look at tracts where complaints have been filed, it looks like they're in tracts that tend to be more white. The other thing I wanted to look at really quick is group summary statistics. So I'm a denizen of the tidyverse. And so you can, because it offers nice methods for grouping data and summarizing data. I also really like the pivot longer and pivot wider. So if you'll remember, we got long data, that is, there is lots of records and there's like a categorical column. So if you have like the variable being like Black, white, Hispanic, et cetera, you have a record for each variable and that value. So there's like multiple values per census tract. You could use the pivot wider method to take that data and kind of explode it out so it's wide. So you have one record per census tract, and then for each census tract, you have like the percent white, the percent Black, the percent Hispanic on down the line. And then the inverse is true for pivot longer. So if you have that wide data, so the inspection data that we have is wide. It's got a lot of information about, I think, investigations. But if you wanted to pivot that longer, you could do that as well. Pivot longer is really useful for charting, which we will see in our example. So here we're just calculating the mean population percentage group with those two groups, like tracts where complaints have been filed and tracts where complaints have not been filed. So we're taking our demographics, grouping it by that binary variable, and then we're calculating the mean of each race or ethnicity. Passing that into pivot longer is going to take what's exploded out this way and make it exploded out that way. And then I made like a quick chart based on the results. So looking at that, we can see, not well, that on the left here is our tracts where complaints have not been filed, and our track on the right is tracts that complaints have been filed, and we can see like the mean percentage white in the tracts where complaints have been filed is higher than the mean where they haven't been filed. So I wanted to stop here and talk about what's wrong with this sort of analysis. So data is not people. Like, just because are we looking at the right thing? You know, is the demographics of where a complaint is filed, is that meaningful? Is it, or would we be better suited looking at like the demographics of the people affected by that complaint? So maybe we want to look at, you know, people living around the water resource that like the complaint is a tributary to, or any other sort of like thing like that. also, like, there are a number of reasons that, complaints can be filed, also a number of reasons they can be closed or investigated. So I want to hop back into our studio to take a look at that. So if you'll remember, if we were just looking at the complaints, it looked like in counties or in tracts where a complaint was filed, they tend to be wider than tracts where complaints were not filed. So you might, you know, look at that and say, oh, wow, it looks like maybe the tracts, wider tracts are getting more of our attention, more of our resources, right? But that is kind of a spurious conclusion, because there's actually a number of complaints doesn't necessarily mean investigation, and then investigation, whether a complaint was answered, doesn't necessarily mean like a decision was made by somebody to investigate. So it turns out there is a number of reasons why a complaint might be closed. We look at our account. Closing. We can see there's like a number of different reasons a complaint might be closed. And if I'm interested in like, are we answering complaints equitably? I'm not really interested in whether there's like insufficient information. I'm really interested in like complaints that aren't within the authority. But this reason here, the discretionary dismissal really stands out to me. It's like, oh, okay, somebody made a decision to pursue this complaint or not. So I can filter for those particular complaints. And then similarly to how we looked at the number of complaints per tract before, we can look at the number of discretionary dismissals by tract. We can join our discretionary dismissals with our complaints to calculate a dismissal rate, because we always want to be cognizant of like, am I making a population map? You can't have complaints dismissed without a complaint being filed. Yeah, and then the number of complaints filed might, actually, I'm just gonna stop there, take that back. So we could calculate our dismissal rate. And then we're also gonna we're gonna make a binary variable. So we're gonna say for each tract where dismissal rate higher than the average overall dismissal rate. So we can then join that dismissal rate data with our tracts. So we have the demographic information again. And then we can plot it to look and see, is there a meaningful difference in the demographics of the tracts where the dismissal rate is higher than average. So what that leads us, and then we're plotting it. So what that leaves us with is this chart, and it's a lot, the difference between the racial makeup of the tracts is a lot less different when we just look at when we look at the disparity between or when we look at the buckets of dismissal rate, then if we looked at like complaints filed and then tried to infer, are we devoting too much of our attention to a particular, to tracts with white people overrepresented. Okay, great. I think I have garbled enough English language today. So I wanted to pause here, open the floor for questions and answers, and also invite Forrest, who's on the call, if you have anything to add about more statistical methods. Love to hear that as well. Yeah. but that's all I've got. At the end of my presentation, at the end of the slides, there's a number of resources for statistical methods that I'm not going to talk through, but they're really good. Just sort of guides to doing it. So if that's something you're interested in, definitely recommend walking through some of these resources.
Thanks so much, Hannah. Molly, jumping back in here. Yeah, I think this probably feels a bit overwhelming for a lot of people, especially because we've got a lot of people on the call who either, have beginner or no experience with writing code and everything. But I think this is very powerful in showing what's possible for us as we try to deepen our understanding of equity impacts of all of our programs and policies across the water board. And it's not so much that every single practitioner needs to know how to do these analyses, but that you kind of come with this idea of, okay, this is what we could look at. You have an idea of what you're interested in exploring, and you bring that to the data subcommittee. So hopefully this is kind of inspiring and not too intimidating in a way that, folks can really see what we're able to understand by digging into the data in with these different methods. Um, so if folks have questions, we are down to our last 8 minutes here. It looks like there's a couple questions in the Q&A box. Some have been answered. We are gonna, I believe, share the slides from this as well as the recording. So you'll have, access to all the links and everything. Um, let's see, it looks like, so Anna did ask about how does the CDC Social Vulnerability Index differ from Cal and Viroscreen? I don't know if you wanted to circle back to that, Anna, if you have an answer for that now.
Yeah, I'm not sure specifically how they differ. If the screen is custom for California and that's covering like the variables you're interested in, then I would probably use that versus the national index. But yeah, I could definitely look into that more.
Yeah, it's interesting because there's also the EJ screen data
Mhm.
versus Cal and Viroscreen. So EJ screen is the US EPA's environmental justice tool. And I'm also curious kind of how they calculate their indices. I really want to see kind of a side-by-side comparison of, if you were looking at impacts using one tool versus another, what would be the different
Mhm.
results that you get? Um, Looks like Anna just popped in to say, appreciate Hannah underscoring that data are not people and data sets don't mean we're doing the equity. How we use, interpret, and act on the data we use is what moves us into operationalizing equity. Yeah, super good to underscore that. And I think it is, also just kind of an imperfect science here. We can look at all the quantitative variables we have, but it might not still tell us exactly what we want to know. And that's where it's going to be really important to communicate with our community groups, our partners, to make sure that we're kind of getting the right idea. And folks, feel free if you have a question that you want to ask, you can raise your hand and I can give you permission to speak. It looks like an anonymous person also asked, how would the code change if you want data for several years? So looking kind of
Yeah.
at longevity. Mhm.
Yeah, so if you're talking about pulling census data, you'll do like a function call for each year that you want. Um, but it's super easy. You just pass um, the year that you want as the year argument. So you can get 2010 and 2020, or if you're using the ACS, you can do, a sequence of years if you want.
Yeah, and I wonder how that would work too if you want to look at cumulative, if we're trying to understand whether our equity programs are having an impact, if how we would approach looking at that over time. These are all important questions.
Yeah, for sure. I know I actually can't remember if the ACS calculates the change for you or if you can stack multiple, not stack, but look at different years and then calculate that.
Mm-hmm.
But that would be an interesting like analysis and an interesting thing to have sort of a toolkit for because you are going to want to look at change in a particular variable regardless of what you're doing, probably.
Definitely. All right, Regina just popped in the Q&A and said, was wondering how you deal with data within blocks and tracks that overlap with boundaries, such as Bulletin 118 sub-basin boundaries. This is a great question. This is what a lot of people at the Water Board are dealing with so many integrated boundaries. How do you get the correct population and race percentages within the sub-basin? This also applies to CDC's social vulnerability index within a sub-basin. And I believe there are certain tools where you can draw your own boundaries. I don't know, can you speak to that a little bit, Hannah?
I think you can draw your own boundaries, and I think it's geojson.io. There's a website where you can do it, and then obviously you can do it in uh, a GIS software like ArcGIS or something similar. But there's a number of methods for dealing with dealing with that overlap. The very basic one that I've used in the past, because the exact precision hasn't been super useful, is or hasn't been necessary, is if you get the proportion of that shape that overlaps with your subbasin. So if you're working with tracts and 50% of a tract falls within the subbasin, you're looking at assigning 50% of that tract's value for the variable to the subbasin. It has been the method I've used before. It's not perfect. And I don't know, Forrest, if you want to chime in, there are definitely more sophisticated and more precise ways of dealing with overlap, but that's kind of the basic and I think simplest one, if that makes sense.
Yeah, that's oftentimes like really good enough. If for some reason it's not, one thing that you can do is to go down to like a block geography, if that's something that you have recently, which are much smaller. And then you can and then say like, that will blocks nest into tracks. So if there's some variable that you care about that's only really available at the track level, one thing you can do is say like, well, I'm going to use the block level to see what percentage of the tract population is within my boundary, and I'll use that proportion uh, for my allocation as opposed to the aerial one. That's kind of like a population weighted. So like, it's like that's oftentimes called a population weighted allocation as opposed to like an aerial allocation, which is what Hannah's talking about. Um, you know, but those are basically, there's some other kind of like much more advanced techniques, which kind of like saying like, well, do we have other auxiliary data that's not census data about like, well, we know that this is like a commercial zone, or we know that this is like this part of it is like a big highway, and so we're not going to allocate people to that. But those techniques can get pretty complicated pretty quickly. We can happy to walk if you guys want to walk through some of those at some point in the future. We can spend a lot of time just talking about just that.
Thanks, Forrest. I think we've got a lot of ideas about where we want to go from here. And I really appreciate everybody being here today. Appreciate your time. Especially thanks to our presenters for walking us through these really interesting and important analyses. Just want to make a quick plug before we wrap up for um, the data subcommittee. So I'm just going to drop the link to our page in the chat, and we'll also send that around in the follow-up email with the recording and slides as well. But on that page, you'll find more about the subcommittee, how to get involved. There's a bunch of different forms that are linked there. If you have a data project, if you're just interested in joining our meetings, you can find all of that on that page. And then yeah, and then Nick just said in the chat, important to know, if this has spurred an interest in meeting with the DataMade coaches individually, please submit the data project form. So you can find that on the link that I just put in the chat. And also feel free to email either Nick or myself if there's any questions that you have, or use that Equity Data Help email address as well. And then as soon as we end the meeting today, you'll be prompted to do a post-meeting survey, and we'd really appreciate just a couple questions. We'd really appreciate it if you could take the time to fill that out so you can help us improve these and have us host more in the future. And with that, I will go ahead and close us out. Thanks again, everyone, so much for being here. More to come.
Thanks so much, everybody. Appreciate your time.
Thank
Bye
you,
now.
Hannah. Thanks, Forrest.
Take care.